Okay, so welcome back to the second video in the implementation series for software engineering. This one is going to be about Lexicon bad smells. So what we talked about last time is trying to go from design into implementation, and how the language or the choice of language that you use can either be implicit, just based on the needs of your client or the needs of your organization, or they can be explicit. They can be set by the contractor, by the person who's actually architecting the solution. We also talked about how the best architectural designs are, in a lot of ways, language agnostic, which means that you could implement them in whatever language you want, and if you make changes, you don't necessarily have to go back in time and do a lot of rework. We also talked a little bit about best practices in terms of having documentation for the way that your code looks, so that people on the team are all kind of coding the same way, and for specific coding patterns and practices that you need to adhere to in order to make sure that everybody's code is the same level of simple. So you're using the same mechanisms to access databases, the same mechanisms to access file systems, so on and so forth. And so what we're going to talk about now is probably the A, most obvious, B, most predominant, and C, most hilariously named thing that can go wrong with implementation, and that's called those are Lexicon bad smells or code smells. So in software engineering research, these things are called Lexicon bad smells, and basically what they are is really bad or poorly named identifiers. And so if you're not familiar with what the term identifier means, these are variable names, they're method names, class names, those kinds of things. So the idea of code smells is they're basically a metaphor for body odor. So if you look at your code and you think to yourself, gee golly, I hope that nobody else sees this code because I would be very embarrassed about the state of my patterns and practices, your code is probably smelly. So if you feel like your code is smelly, then whoever comes behind you and tries to fix bugs that are in your initial implementation, it is probably going to be hard for them to do their job, and they're probably going to also feel like your code is smelly. It's unlikely that they're going to feel that your code is better than you feel your code is, because you are more familiar with your code than they are. So it is always best to try to do something about this situation prior to committing it to the code base or to the repository, because once you commit it, potentially other people are going to see that and say, man, this guy always knows what he's doing, or this lady is really great at her job, so I'm going to copy and paste this code, or I'm going to use these same concepts. And then code clones pop up all over the place with the same level of smelliness, and now you've effectively propagated this bad practice to the rest of your team. So the best thing to do is get in the practice of being a little bit paranoid before you commit, particularly to a patch branch or something like that that's going to ultimately go out for testing, because your smelliness could potentially lead to breaking changes and things like that, which we're going to talk about next week, that you definitely do not want to be responsible for. So if you can, you should take the time to kind of read through your code line by line, change by change, and put yourself in the shoes of a freshman in introduction to programming. If you can understand it as the most basic user, then you can be fairly certain that your coworkers or your teammates will also be able to read it, unless they kind of don't meet the minimum requirements to even be on the team. So what you want to do is be mindful of everybody else's experience with your code, and that's what this is all about. So the variable names themselves should meet two pretty specific requirements. Variable names should always be consistent, and they should be meaningful. Consistent variable names have no ambiguity, because everybody needs to understand what the variable itself is referencing specifically. So if you use something like obscure acronyms, or if you shorten words in non-standard ways, then you will not necessarily know what the acronyms or what the shorthand versions of those words actually mean. And so this is very similar to pronoun reference errors in English. You don't necessarily understand what the ambiguous variable name is referencing, and so it's really, really hard for you to understand the purpose of the variable or the method or the class without reading through a bunch of code. And your read through the code could be incorrect, or your read through the code could be influenced by all sorts of different environmental factors that can make your understanding of the code wrong, or your understanding of the situation take longer than it actually should. The second thing is variable names should always be meaningful. So if you feel like you have to put a comment above the variable name to explain why it's named the thing that it's named, you should probably rename the variable. That's the sort of telltale sign. What you want is variable names that are expressive. A person will read them and kind of understand immediately what is going on. We talked at the very end of the last video about sort of these very documented ways, and I believe there is a paper that goes through and catalogs the worst or the smelliest identifier names, but there's one example where a person actually used his ex-girlfriend's names as variables. So if you think about in C# or something like that, getting a null reference exception from a Donna or something, you're going to have no idea what's going on, but if the variable has a meaningful name, you'll at least know where to go and try to look to find it. There is this push that is maybe waning now, but was very, very popular a couple of years ago, called self-documenting code. The idea is that your code and the identifiers inside of your code would be so well understood, they would be so meaningful, and they would be so consistent that you don't actually have to have any comments. The code itself is so easy to read that adding comments only makes things more complicated. And so there were several very large organizations that had fairly strict no comment policies. So if you tried to push code that had comments into a production line, they would throw errors and tell you that you failed a gate check and you had to actually go in and remove your comments in order to be promoted to production. In practice, this is kind of a hard thing, but in theory, it kind of makes sense, right? The biggest issue with comments is that they become outdated, and so you could go into a piece of code and you could modify the code in order to fix a bug, but if you don't change the comment and you've changed the way that the code works, then the comment will say one thing and the code does a different thing. And so then the next person that comes in and reads the comment is going to be pointed in the completely wrong direction by what the comment is saying. And so that is actually more harmful from an organizational perspective than having no comment at all. So the idea is if you can simplify your algorithms, if you can simplify your naming conventions enough, you can do away with comments entirely, and your code itself should be obvious to a person with minimal skill, and you should be able to live your life comment-free. And so because you don't have any comments, you won't have outdated comments, and because you don't have outdated comments, you won't have the technical debt associated with having outdated comments. The problem with this is that you don't necessarily have the guarantee that a person is going to have the minimum level of understanding that you expect them to have. So potentially you're going to write a piece of code. It is going to be contextual. It's going to be based on libraries that are very popular in the day. And then you're going to potentially have a junior developer that's hired a decade later trying to read that code, and it's not going to make any sense because the design paradigms or the libraries are completely different. The Java syntax is completely different. The C# syntax is completely different. And you could also have QA engineers who are very good QA engineers that are trying to go and read your code before they try to stop a Scrum meeting or try to send a bunch of emails that slow you down. But they will not be able to understand all of the syntax where they would be able to understand a sort of natural language English or Spanish comment. So from a practical perspective, having self-documenting code is kind of okay, but you have a lot of situations where it could actually hinder your organization quite a bit. You also have situations where if you cannot have comments, your code might contain variable names that are crazy long. And so in languages, particularly languages like JavaScript, where you don't necessarily have to have a lot of structure around the creation of a variable, you can have situations where people will put whole sentences as the name of a variable, and it becomes extremely difficult to understand what all of these things are doing. So basically, there are situations where people can overdo it, and they actually essentially just put the comment as the variable name, and that can also cause a lot of confusion. So in general, comments are a great idea. They're there for a reason. You shouldn't overuse them. You shouldn't underuse them. And when you update code, you should always make sure that you're updating the comment so that there's no sort of phasing, there's no out of sync comment for the code that is actually being commented. So if you look in the book, figure 15.1 to be specific, these are all of the things that are supposed to be in what are called prologue comments. So prologue comments are comments that precede a class, and so you want to, or a method, you want to list a whole bunch of stuff, and you can think about these, if you're familiar with Java, it's essentially entries in a Java doc. So you can see that this is a tremendous amount of information, and not a lot of it potentially is going to get used. So obviously a brief description of the artifact, that's fairly helpful information, but the date that the artifact was approved, that's probably somewhere else in a requirement somewhere or in documentation somewhere. And so this is a perfect example of somewhere where old or outdated information could be left around because the person doing the coding may not even care or have access to those other documents. And so this could be very misleading if it's left out of sync with the actual documentation. So you have to kind of take this with a grain of salt. So this huge list is extremely optimistic, but if you have a lot of the sort of core pieces of those prologue comments, it will help you a lot. So if you were trying to program some extremely niche piece of the system, particularly framework components of the system, what you want is you want really robust comments around the purpose of the class, what the class is trying to do, the general architectural concepts of the class, all of the classes that are potentially going to be called from that class, and all of that information being in natural language also makes your code more searchable. So if a person is trying to search through the code with something like Control F or with grep, they will be much more likely to find something that is relevant to their search if they have a natural language sort of explanation of what the code is supposed to be doing coded in a prologue comment. So prologue comments are sort of diametrically opposed to encode comments. And so encode comments are the sort of line by line kind of breakdown of what an algorithm is trying to do. And so if you find yourself commenting every line of a method, for example, that is a telltale sign that you should refactor the method that you're trying to create. Basically what you want is for encode comments to give very high level information, and you might have one every 5 or 10 lines of code. In particularly esoteric algorithms or particularly problematic pieces of code, you might leave comments to not do specific things or something like that, and those are kind of okay. But if you find yourself just typing books of information in a piece of code, that typically means that piece of code needs to be re-engineered in some way. So there is a concept of to-do comments. So to-do comments are encode comments that are basically markers that tell you that at some later date something needs to be done to this code. So this is a telltale sign that you have cut a corner or you've kicked the can down to the next sprint or something like that. And so if you haven't implemented a generic solution to a problem and you recognize that you're going to need a generic solution later, you might leave a to-do to come back and sort of fix that later. At very large firms, what you'll find is people use to-dos along with a bug number. So they will actually put the bug number in the to-do comment, and they will raise a bug to come back and fix or refactor the code that they're talking about. And it's a very nice way of kind of linking technical debt that you know exists in the system with tasks that you know need to be done in order to make the piece of software ready to go to market. So for whatever reason that kind of escapes me, there are tons of organizations that have publishing rules or gate checks in their production sort of publish system that tell them that to-do comments are left in production code. And what will happen is you will have to scramble to eliminate those to-dos at the 11th hour prior to publishing a release. My whole sort of soapbox about this is that defeats the whole purpose of a to-do. Simply because you eliminated the to-do comment does not necessarily mean that you did the work that the to-do was reminding you to do. And so in the software engineering research module, we're going to talk specifically about traceability, which is what my PhD is actually in. And traceability is really, really important to make sure that you are actually shipping a solid piece of software that doesn't have a lot of known issues in it. And in this case, what you're doing is you're actually eliminating traceability by eliminating the marker that tells you that technical debt exists somewhere specific in your code stack. So I am very anti eliminating to-dos. If you're going to have a rule that says you can't have production code with to-dos in it, that means that you really need to resolve those to-dos, not just eliminate them from the code so that you cannot think about them. So we talked a little bit about this in the previous video. Style guides basically are the same as style guides for a newspaper or something like that. And as weird as it may sound, adhering to common things like formatting, how indentation is supposed to work, whether or not you're supposed to use curly braces around blocks of code, for example, all of this really hinders your ability to understand code if you're doing something differently than all of your teammates are doing. So things like Visual Studio, things like JEdit, all of these different IDEs, Eclipse, they have keyboard shortcuts that allow you to specify formatting requirements and then keyboard shortcuts that enforce those formatting requirements. Many companies have automatic formatting routines that run when you check in code. And the idea is if you are checking in unformatted code, that is roughly equivalent to charging some trivial thing on your credit card. Sure, it's extremely easy and convenient to do, but ultimately you're going to potentially pay 24% interest on your cup of coffee, which is kind of stupid. And if you think about the logical extreme of this, if you take a piece of JavaScript and you minify it, if you've ever seen minified JavaScript, you will know that it is almost impossible to meaningfully troubleshoot minified JavaScript when it gets to a certain size. So if you are checking in one gigantic line of C code, it's going to be very hard for your teammates to do their job, and that's going to make the entire organization less efficient than it otherwise would be. So this is basically saying that even on that continuum, closer to something more reasonable, it still has a negative impact on your organization. You should all have the same formatting requirements. So while style guides give you an idea of what the code should actually look like, code guides give you an idea of what the code should actually be doing. And so many organizations, typically the larger ones, have very specific code guides that tell you the standards for providing access to their code base. And so even very large open source systems have exactly the same idea. It is so important that Microsoft even has a code analytics tool that allows you to enforce standards on code that's being committed to a repository at build. So you can trigger a whole bunch of warnings that say you're not supposed to have a variable that isn't ever referenced, for example. This is just dead code, or you're supposed to have using statements around reading files or whatever, and you can customize those messages, or you can customize those requirements to your specific company, so that you are getting very fine-grained control over the code that people are actually checking in. The problem with this is that because you can do so much customization on these errors and on the actual situation that you're trying to police, you can implement effectively arbitrary decisions that actually hinder you more than help you. And so if you think about what a bad code standard might look like, it looks something like this. No class ever will have more than 500 lines of code. So what can happen is you can get a very critical bug, and the critical bug can only be fixed by this generic approach, and the generic approach itself has 501 lines of code. And so this 501 lines of code can be the greatest 501 lines of code that's ever been created, but when you check it in, a big red light goes off, alarms sound everywhere, and then you're restricted from actually checking in that critical fix to the branch. So what has happened is this universal statement that all code that is more than 500 lines of code is bad has restricted your ability to do your job in a meaningful way. So there's a whole section about this in the textbook. This is a thing that we're going to harp on a little bit in the quiz this week. You have to be very careful about universal statements in coding standards. What you want is you want to allow people enough wiggle room to do their job, but you also want to enforce some sort of code review potentially, or you want to make it a little bit harder to check in huge pieces of code, or you want to make it a little bit harder to bend the rules where they need to be bent. So if we try to make that coding standard a little bit better, you could have something like no class will have more than 500 lines of code without being reviewed by a senior developer. And so what happens now is that 501 lines of code can be checked in and it can be built. However, what will happen is it will be sent to a more senior developer on the team to be reviewed. And so as soon as it's reviewed and okayed, then it will be able to be adopted into the branch and everything is fine. So what you have to be careful about is we talked at length about agile standards and agile development methodologies very early in the semester. If you use really rigid coding standards, that undoes all of that agility. The more rigid your coding standards are, the less agile your team can be. So what typically happens is people want to use case tools to keep their code clean, but if you go too far to one extreme, you can cripple the entire team's ability to react to things. So like everything else that we've talked about in the entire semester, what you want to do is kind of strike a balance. You want coding standards that remind people that huge pieces of code are typically not great, but allow them a way of checking in large pieces of code if the situation merits a large piece of code. So that's the long and short of the Lexicon bad smells and sort of coding practices part of implementation. Next time we're going to talk about is the absolute kind of hardest part of all of this called integration, where you take all the subsystems that potentially people are working on in parallel and then stitch them all together with pieces of code that are the most likely to break. So I hope that this was informative, and I will see you in the next video.